Good morning. We're going to review factoring the sum or difference of two cubes. So we're going to do three examples. Hopefully they will refresh your memory. If not, ask me questions. All right, so factoring the sum or difference of two cubes. This really implies the word perfect cubes. Um, Most people don't have a whole lot of the perfect cubes memorized, but they are important. Um, the first couple, 1, 8, 27, 64, 125. I think the next one's 256, but even with all these years' experience, unless I'm actively using them at the moment, I kind of mess them up. So I'm just checking 216. I was close. I think the next one's 343. Yes. Um, 512. And we'll do two more, 729 and 1,000. All right, so those are the most common ones you'll see, but of course you always have access to your calculator. Again, like difference of two cubes, or squares, this is a shortcut method, although it's much easier to do sum or difference of two cubes this way. Also, throughout this course, you're going to need to be able to recognize when to use them. So I'm going to go through the questions to ask yourself that I use all the time. Question 1, is there a GCF? So you're going to look at the problem that you're given and check for a GCF. And there is not a GCF, so we're going to continue. Second question, is it a binomial? Well, binomial means two terms, so yes, this is a binomial. The next question, are they perfect squares? Well, this one, 64 is a perfect square, but x cubed isn't, so no, and neither is 125. So this is not a difference of two squares problem. And then you need to ask yourself, are these perfect cubes? And yes, they are perfect cubes. For perfect cubes, you can have a sum or difference. So the fact that this is a plus is fine when we're talking about cubes. If they're squares, it's not okay. All right, so yes, this is a sum of two cubes. And so the first thing you're going to do is take the cube root of each term. All right, so I'm going to do the same style that I did for the other one and take the cube root. The cube root of 64x cubed is 4x. The cube root of 125 is 5. Now, this is where people get confused. This is absolutely a memorizing thing. You need to memorize this pattern, okay? So when it is plus, when it is a sum, you're going to add the factors together. So 4x plus 5, okay? The second part is a little bit different. When it's addition, the first sign you write after that is the opposite. It's negative, okay? You're going to take the first term and square it. 4x squared is 16x squared. Okay, this one squared. You're going to put a minus. It's always the opposite sign. And then you're going to multiply the two terms together. 4x times 5 is 20x. And then it's always a plus here. You're going to square the last time. That is the answer. Okay, so I'm just going to put up here what we do. This is 4x squared. This is 4x times 5. And this is 5 squared. Okay, you've got to do a bunch of these to get that down and memorize it. If this was a minus, then you would do a minus b, a squared plus ab plus b squared. Okay, so this sign is the same as the one in the problem, and this one is the opposite. It's a memorizing thing. You've got to memorize it. And just to review how to check your answer if you wanted to, you can multiply these by like distributing a bunch of times, or you can make the box, which is the easier way to do this kind, really. 4x, 5, 16x squared, negative 20x, and 25. If you multiply all this stuff out, you're going to end up with 64x cubed plus 125. I'm not going to do that part, but if you need me to, just contact me and I'll go through that with you. Okay. Basically, what's going to happen is these two parts are going to cancel. Two examples. Now, if you feel great and you want to try it on your own, go ahead. If you feel like you need to watch again, I'm going to go through the process again. Question 1. Is there a GCF? No. Is it a binomial? Yes. Is this a perfect square? No. So it's not a perfect square. Is it a perfect cube? Yes. Is this a perfect cube? Yes. Okay. So it's a difference because we have negative of 2 cubes. We need to take the cube root of each term. The cube root of the first term is 2x. The cube root of 27 is 3. Remember, hold on, let me back up a little bit. When it's subtraction, you keep subtraction. So our first parenthesis is going to be 2x minus 3. Then we're going to square the first term. 4x squared plus, it's always the opposite sign there, multiply 2x times 3 is 6x. Square the last term. And I'll put those back up here just in case for reference. Square the first term, multiply them, square the last term. All done. That's the answer. Pretty nice, right? All right, let's look at the next one. Is there a GCF? Yes, 2. So we're going to factor out a 2. All right, checking inside, factoring completely. This is a binomial with perfect cubes. So this is a perfect sum of 2 cubes. So we're going to take the cube root of each term. The cube root of x cubed is x. The cube root of 64y cubed is 4y. So we're going to have x plus 4y. Remember, the first set is the same sign. Square the first one. Opposite sign. Multiply together. Square the last one. The end. Pretty nice, right? All right, and again, I'll just add here, it's the first term squared, the 2 terms multiplied, and the last term squared. And you know what? By doing that, I just realized I forgot to add my square right there. That is literally all there is to it. I hope that helped you. Remember, this is super powerful, so please try to memorize that.